So this video is for integrated one. It's the linear systems and equations work on worksheet. So on each of these, you want to make sure you define your variables. You write two equations and two variables. You solve the system algebraically, showing your work, and then write your answer in a complete sentence. So on number one, you sell tickets for admission to your school play and collect a total of $104. Admission prices are $6 for adults and $4 for children. You sold 21 tickets. How many adult tickets and how many children tickets did you sell? So I'm going to define my variables. And I am going to let A equal, and this is kind of the key thing here. We want to make sure we're answering the proper question. It's how many adults. This is going to be the number of adult tickets and the number of children tickets. So let A equal the number of adult tickets, and we'll let C equal the number of children tickets. Okay, and then I'm going to write two equations. So one equation is going to be dealing with that they collected a total of $104. Each of the adult tickets cost $6 and the children tickets $4. So we're going to write an equation for that. We also have that we sold 21 tickets total. So that's going to be a second equation. So for my first one, I am going to write six A plus, because that's $6 for each of the A number of adult tickets, $4 times each of the C number of children tickets, and that's going to equal $104. My second equation is going to be the total tickets, which is 21. So I take A, which is how many adult tickets were sold, plus C, which is how many children tickets were sold, and that's going to be 21. And so now what I'm going to do is I need to multiply one of these equations by something so that I can either eliminate my A's or C's. I'm going to multiply by a -4. I'm going to keep the top equation as is. 6A plus 4C equals 104. The second equation, I'm going to make -4A minus 4C is equal to a -84. Then I'm going to add these two equations together. I'm going to get 2A. One second. I am going to get 2A is equal to 20 divided by 2, and I get A is equal to 10, which means if I look at this equation right here, where there's 21 tickets total, that means my C is going to be 21 minus 10, or 11. Okay, I can put in to the A plus C equals 21. My 10, I'm going to subtract 10 from both sides, and I got C is 11. So those are our answers. And then, of course, we're going to write it in a complete sentence. And so there were 10 adult tickets and 11 children tickets sold. And that's going to be our answer. On number 2, your family goes to a restaurant for dinner. There are 6 people in your family. Some order the chicken dinner for $14.80 and some order the steak dinner for $17. If the total bill is $91, how many people ordered each type of dinner? So right here, how many people ordered each type of dinner? So I'm going to have a variable for the number of chicken dinners and the variable for the number of steak dinners. Okay. So let C equal the number of chicken dinners. And I'm going to let S equal the number of steak dinners. So when I'm looking at this, there are 6 people in the family total. So that means that there were 6 dinners. So if I'm going to write an equation for that, I'm going to take C, which is how many chicken dinners, plus S, I'm going to do it as a cursive S, so it doesn't look like a 5, is equal to 6 dinners total. And then I am going to be looking at the chicken dinners cost $14.80, the steak dinners cost $17, and the total bill was $91. So that's going to be the second equation. And for that equation, I'm going to take $14.80 times C plus $17 times S is equal to $91. I think I'm going to multiply the top equation by a negative 17. I just rather not do it by the decimal. So I'm going to get a negative 17C minus 17S is equal to, and 17 times 6 is 102. So that's going to be a negative 102. I'm going to rewrite that second equation, 1480C plus 17S is equal to 91. I'm going to add these together. And when I take a negative 17 plus 1480, I get a negative 2.2C. My S's cancel out. And a negative 102 plus 91 is a negative 11. I divide that by negative 2.2. And when I do, I end up with 5 chicken dinners. Now, remember, there were 6 people in the family total. So that means that the steak dinner is one steak dinner. So we write our answer in a complete sentence. So the family had 5 chicken dinners and 1 steak dinner. On number 3, so Casey orders 3 pizzas and 2 orders of breadsticks for a total of $29.50. Rachel orders 2 pizzas and 3 orders of breadsticks for a total of $23. How much does a pizza cost and how much does an order of breadstick cost? So this is what my variables are going to be: the cost of a pizza and the cost of breadsticks. Okay, so let P equal the cost of a pizza, and B, I'm going to do capital B just so that when I write it, it doesn't look like a 6. So B equals the cost of breadsticks, an order of breadsticks. Okay, so on this. We've got Casey. Casey had 3 pizzas and 2 orders of breadsticks for $29.50. That's going to be one equation. So for that equation, I'm going to write 3 pizzas that each cost P dollars plus 2 orders of breadsticks, which each cost B dollars, is equal to $29.50. Then I'm going to have a second equation, and that's going to be dealing with Rachel. She had 2 pizzas and 3 orders of breadsticks for $23. So we had 2 pizzas, each with that cost P dollars, plus 3 orders of breadsticks, which are each B dollars, and that's $23 total. So I'm going to either get rid of my P's or my B's. So in both cases, I can get either 6 in front of my P's or 6 in front of my B's. It doesn't matter. I think, and I'm going to have to multiply both equations by something. So let's see. I think I'm going to multiply the top equation, let's say by 2, which means I'm going to multiply the bottom equation by a -3. I'm getting rid of my P's right now. That's what I'm going to do. So when I do this, I'm going to get 6P plus 4B is equal to, and $29.50 times 2 is going to be $59. And when I multiply the bottom one, I'm going to get -6P minus 9B is equal to, and when I take 23 times 3, I get a -69. I'm going to add these 2 equations together. My P's cancel out. I get a -5B is equal to -10. I divide by a -5, and an order of breadsticks is $2. So now I'm going to plug it into either equation. I think I'm going to choose the pink one, the second one. So I am going to do 2P plus 3 times 2, that's my B, is equal to 23. So 2P plus 6 equals 23. Subtract the 6 from both sides, I get 17. I divide by 2 and I end up getting $8.50, 8.5 for the pizza. The cost of a pizza is $8.50, while the cost of an order of breadsticks is $2. The next question, number 4, a farmhouse shelters 10 animals. Some are pigs, some are ducks. Altogether, there are 36 legs. How many pigs are there and how many ducks? So those are going to be our variables, the number of pigs and the number of ducks. That's what I'm going to have to represent. So I'm going to go let P equal the number of pigs, and I will let D equal the number of ducks. And then we're going to write our 2 equations. So one equation is going to be that there were 10 animals, okay? So for that equation, I'm going to write P plus D equals 10. My second equation is going to be dealing with 36 legs. So for my second equation, I need to understand that each pig has 4 legs. So I take 4 times the number of pigs, P. My ducks have 2 legs, so 2 times the number of ducks, D, is equal to 36. Now, I can multiply the top equation by a -2 to get rid of my D's. I think I'm going to try something different in this one. I think what I notice is I could divide by a -2, a -2, and a -2. For my second equation, I'm going to keep my first equation as is. You're allowed to divide also. I just want to show a different approach. So if I divide my bottom equation by a -2, I get a -2p minus d equals a -18. I can then add these two equations together. I get -p is equal to -8. Divide both sides by -1, and I have 8 pigs. Well, if I have 8 pigs and there's 10 animals, that means there are 2 chickens. So I'm going to write our answer in a complete sentence. There are 8 pigs and 2 chickens at the farmhouse. Number 5. A class of 195 students went on a field trip. They took 19 vehicles. Some were cars, some were buses. If each car holds 5 students and each bus holds 25 students, how many buses and how many cars did they take? Okay. So for this, when it says how many buses and how many cars, that's number of buses and number of cars. So let, and I'm going to do capital B, B equal number of buses and C be number of cars. And one equation is going to be that there were 19 vehicles total. So for that equation, I'm going to write B for the number of buses plus C for the number of cars is equal to 19. For my second equation, I know there's 195 students total. Each car holds 5 students. Each bus holds 25 students. So my buses hold 25. So I'm going to go 25 students times B buses plus the cars hold 5 students. So 5 times C, number of cars, is equal to 195. Now, again, I can multiply the top equation by a -5, but again, I'm going to show us a different approach. I'm going to divide this by a -5, a -5, a -5. I'm going to keep the top equation as is. B plus C equals 19. The bottom equation is going to end up being a -5B. My C's cancel out. Well, I shouldn't say that. They will cancel out, but I have to write them. Try it one more time. So when I divide, I get a -C equals, and 195, -195 divided by -5 is a -39. I add these two equations together. I end up getting a -4B is equal to a -20. Divide both sides by a -4, and I get B is equal to 5. Now, since there were 19 vehicles total, that means that my cars are going to be 14. So my sentence, there were 5 buses and 14 cars for the field trip. On number 6, Eva and Nicole went to a store that sold shirts and hats. All the shirts were the same price and all the hats were the same price. Eva bought 2 shirts, 5 hats for a total of $154. Nicole bought 3 shirts and 4 hats for $168. What is the price of each shirt and what is the price of each hat? That's going to be my variables, the price of a shirt, the price of a hat. So let S equal the number, not the number, sorry, the price of a shirt, and H equal the price of a hat. So I'm going to write 2 equations. Okay, so one equation is going to be that 2 shirts and 5 hats cost $154. So 2 shirts times the cost of a shirt. And then again, I'm going to do my S as a lowercase cursive s so it doesn't look like an 5 halfway through. Plus 5 hats is equal to $154. And then my second equation is going to come from 3 shirts and 4 hats for $168. So 3 shirts, so 3 times S being the cost of shirts, plus 4 hats, so 4 times H, which is the cost of a hat, is equal to $168. Now on this one, I can either try to get the same number from my S's or my H, either 6 in front of my S's or 20 in front of my H. I think I'm going to try to get 6. So I'm going to multiply the top one by, let's say 3, and the bottom one by -2. So when I do that, I get 6S plus 15H is equal to, and 154 times 3 is 462. My bottom equation, when I multiply by -2, I get a -6S minus 8H, and 168 times a -2 is a -336. So I'm going to add these 2 equations together. My S's are going to cancel out. I end up with 7H is equal to, and 462 minus 336 is 126. I'm going to divide by 7, and a hat costs $18. So I'm going to plug this into either equation. Doesn't matter which one. Let's say I do it into the top one. So I'm going to go 2 times S plus 5 times $18 for a hat is equal to 154. So 2S and 18 times 5 is 90. I'm going to subtract 90 from both sides. And when I do, I get 64. So I'm going to have 2S is equal to 64. I divide by S and I get $32. So my answer, the cost of a shirt is $32, while the cost of a hat is $18. On number 7, Philip collects 2 kinds of baseball cards, the tops and the flare. The best kinds, the tops is worth $5.50. The second kind, the flare, is worth $3.90 each. if he has 46 cards total and they are worth a total of $209.80, how much of each kind are there? So for this one, how many of each kind? I'm going to have T represent the number of tops and F represent the number of flare. Okay, so let and I'm going to do a capital T and I'll just do a capital F equal the number of tops and F equal the number of flare. So now I'm going to write two equations. One equation, let's see. The first kind, so the tops is worth $5.50 each. Flare is worth $3.90 each. And he has a total of $209.80. So I am going to write 5.5 T plus 390 F is equal to 209.80. Second equation is going to be dealing with 46 cards altogether. So that means T plus F is equal to 46. So I'm going to multiply the bottom equation by something. Doesn't matter what. Maybe I'll do it by the smaller of those two numbers, negative 3.90. So the top equation is going to stay. So I'm just going to rewrite it. The second equation, I'm multiplying by a negative 390. So I'm going to get a negative 3.90 T minus 3.90 F is equal to, let's see, 46 times a negative 3.90 is a negative 179.40. So I'm going to add these together. And when I do, I end up with 5.50 minus 3.90, which is 1.60 T, is equal to 209.80 minus 179.40 is 30.40. I divide by 1.60 and I end up with 19. Now we know there's a total of 46 cards. So if I take and put 19 into this equation, but basically what I'm doing is I'm taking 46 minus 19 because that's going to be the rest. I end up with 27 for my other cards. So my sentence, again, remember, always write a complete sentence. The number of tops baseball cards is 19, while the number of flare baseball cards is 27. And number 8. You bought meat for Saturday's cookout. A package of hot dogs cost $1.60. A package of hamburger costs $5. You bought a total of 8 packages of meat. You spent $23. How many packages of hamburger meat and hot dogs did you buy? So, how many number of packages of hamburger meat and hot dogs did you buy? So that's going to be our variables. So I'm going to have I'll do H for hamburgers. Let H equal the number of packages of hamburger meat. Let's pull this out a little. And I'm going to put D for hot dogs. D is equal to the number of packages of hot dogs. Now for my first equation, we have the hot dogs cost $1.60, hamburger cost $5. We spent $23 total. So that equation, I'm going to take the hot dogs, which is going to be D. $1.60 times each D number of hot dogs plus $5 times each H number of hamburger packages is equal to $23. Second equation is going to be dealing with 8 packages total. So that one is going to be D plus H is equal to 8. I think in this case, I just would rather not have to deal with a decimal. So I'm going to multiply the bottom equation by a -5, even though maybe $1.60 is smaller. So this is going to stay 160D plus 5H is equal to 23. Second equation is now -5D minus 5H is equal to a -40. We add those two equations together. And when I take 5 minus $1.60, I end up getting $3.40 negative. And when I take 23 minus a 40, I get a -17. I'm going to divide each side by a -340. And when I do, I end up getting 5 packages of hot dogs. Now there are 8 packages total. So that means my hamburger packages was 3. So you bought 5 packages of hot dogs and 3 packages of hamburger meat for the cookout. And that's the end of this video. Hopefully this helps those of us who are having trouble writing and solving these systems.